Position, distance are the same thing. So we had distance slash position. That is like our f of x. Now, sometimes you see it as s of t, whatever, okay? Doesn't matter. D, I don't think it'll ever be d of t, but s of t, stuff like that.
Cool, I'm sorry, my phone's being weird.
Your velocity is f prime of x, and your acceleration is f double prime of x.
The phone ringing.
So the point is that you need to be able to understand where you're at in that. Hello?
The Lord.
One for the plug.
Based on the problem, based on the actual problem giving you acceleration, how do we get from acceleration back to velocity?
That's an antiderivative.
It's an antiderivative or integral. Okay, same thing. So the idea then is what you need to take an antiderivative of the acceleration to get the velocity. But what are you always going to get when you take the antiderivative at the end? What do you always have to remember? A plus c. So there's no way for us to answer a question about a velocity of anything unless we know what that c is. That's where the plus c is going to be applied on the AP test. So in this question right here on your work, we have this piecewise function. They want us to take the antiderivative of each of those, but both of them are going to have a plus c. And then you will take some information given you in the problem. We'll call it an initial value, an initial point. Okay? So in this case right here, it says at what time does the rocket begin to descend? Well, that means we need to know when our velocity is negative. Again, I'm going to reframe this question. Okay? I'm going to reframe this question just in a way that will be a little bit more like what the quiz is going to be. And that is going to be something like this. They're going to want to know what the velocity is at a specific time. Okay? Or they're going to want to know what the velocity function is when they give you an initial condition. Okay? So, how does that look? Let me make sure I...
He's really feeling geeked up because the camera's in his face, I feel like.
Well, I told him. I'm doing this for Cole.
So,
Cole, I'm doing this for you, buddy.
I'm just going to use the top function for our purposes here. And again, this is still much more difficult than what it will be on the quiz. So if our A of t is equal to 20e to the negative t over 2, okay? This is what will happen. You'll be given your acceleration function, you'll be given an initial condition for velocity, and you'll be given an initial condition for position. And they're going to want the position function. So how many times am I going to need to take an antiderivative?
3.
Twice.
Oh,
okay?
wait.
But understand, you've got to find your c in both instances. So on this paper it says,
If you're looking for speed,
this has an initial velocity
like
of
the
0.
derivative.
What does that mean? It means that v of 0 equals 0. We'll use that when we take the antiderivative.
Oh no.
V of t is
Oh no,
going to
Cole.
be 20e to the negative t over 2 divided by negative 1/2, which is
Cool,
equal
buddy,
to
I'm sorry, but I'm also writing this down.
40e to the negative t over 2 plus c. You guys with me? All I do is take the antiderivative. I will use this to figure out what my c is. My velocity is 0, so this is my v of t. So if my velocity is 0 at t equals 0, then I can solve for my c. So it looks like my c is going to be equal to 40.
Yep.
Because this will be equal to 1, negative 40 plus 40 is equal to 0. So v of t is equal to negative 40
All right, Chris, you got
to the negative
shaky
t over
hands.
2 plus 40. Now I can do my position. What do? I just take the antiderivative again.
Of that.
So now this will be x of t is the way that they're going to say it. X of t is a position, a term. So x of t is going to be 80 e to the negative t over 2 plus 40t
Well.
I believe you. You got this, man.
Thank you for that, Horace.
You're welcome.
Give him some words of encouragement.
You got this. Just do better than 10%.
How about you, Drizzy?
The position one.
All right, cool. Welcome back, buddy.
Sure. What is it? What is it? T. Is there a hint on that one? Hey, what's the hint? It's the double angle formula, right?
All right, Cole. Just saying this one. This one's really fucking weird, Cole.
Okay, this one's an interesting one because you are required to use a little bit of trig on this one, which a lot of you probably don't remember. Or in my class, for example, we didn't even get to this because of all the days that I missed. This is part of the thing we skipped over. It's not difficult. It's just knowing some of your identities and some of your formulas. So one of the things that you learn in trig is that the sine of 2 theta is equal to 2 sine of theta cosine of theta. Okay? No, I said one of the things in trig, we didn't do double angle formulas. Okay? So this is a double angle formula. So how can this be applied over here? Well, it's actually really simple because we already have our sine of theta and cosine of theta. We just don't have the 2. So here's what you do is you bring the 2 over here and make it 1/2. So I'm going to replace the cosine of t and sine of t with 1/2 sine of 2 theta. So this will now look like the integral of 1/2 t sine of 2t. And then you just do integration by parts from there. Now, here is one thing that we need to point out, and again, you're not going to even know this for the quiz tomorrow, but it's just good knowledge. When you take the antiderivative of sine of 2t, it works the exact same way as an e function. It will be the antiderivative, exactly with the 2t there, divided by the derivative of the 2t. Because you have to compensate for the, it's like basically the reverse chain.
So, maybe.
Because when I take the derivative of something with 2t in it, I end up with a 2 out front. So because there's nothing really out front of it right now, I've got to compensate when I were to retake the derivative to get rid of it. It would be sine of 2t divided by 2. Or 1/2 sine of 2. Okay? So, I mean, you can probably do by parts from there, no problem. I don't want to go through, a ton of stuff.
Cole, if you're somehow still listening to this, I apologize for the amount of blur. But there's quite a lot of motion going
Well,
on.
this would actually be your g prime. So f would be 1/2 t. G prime would be sine of 2t. Your g would be negative cosine of 2t divided by 2. You with me? No.
My arm is getting tired.
It's hard being
Guys, ln of x.
I know.
What's the integral of ln of x?
X, ln x minus x.
And you can, if you want to utilize that without using integration by parts on the quiz tomorrow, have at it. What? The integral of ln of x, is in the notes, is x ln of x minus x plus c. And the final, sure.
I'm gonna get the jumbotest no part. So I'm gonna make the biggest no part.
So it's x ln of x minus x plus c.
Owned.
3 centimeter by 5 centimeter.
Well, then I have wait.
Whatever 3 by 5. Alright, what else? on integration by parts? Is that the one right before this?
Oh, there's an I too.
What do you do to integrate that?
You can bring out 1 over x.
What?
You can bring out 1 over x.
Just bring out 1 over x. Okay, so what would Bender said? Divide out your x before you do anything.
I'm still
Okay?
right.
There will be a question like this. This is one of your normal integration problems. Do not do integration by parts. It's not an integration by parts problem. You just need to divide out your x first.
I respect that, Jizzy. You don't have to on this.
There is no tabular unless it's integration by parts. This is a regular integration.
Thanks, man.
All right. So other than that, okay, power rule. Make sure you know your power rules. Make sure you bring everything up to the numerator before you start integrating. When it comes to integration by parts, make sure you know your e's, right? Make sure you know your ln's. Make sure you know your trigs, right? Especially sine, cosine, and tangent. Okay, now, do we want to go through and see if we can figure out doing tabular with one of those long problems?
Yeah.
So that's the answer.
Yeah.
No, you gotta integrate.
No, but that's easy though.
Of course.
Yeah. Don't be scared.
I'm
I'm
already
gonna learn it a
scared.
day.
We divide down x.
I'm scared.
I'm gonna learn it a day. I've done it before.
That was me last night, dude. I was like big brain, dude.
I've been to
All right,
videos you guys
so
before. I've done it.
Dude, I was mega mind last night.
that was the long one.
Number 10?
Is it number 10?
Number 10's pretty long.
Is that the one where you have to where it cycles around and you have to add to the other side?
This is tabular version of number 8, Cole.
All right, so what did you? Not that I think it matters in this case, but what did you guys use as your f?
I use
Negative 3x is your f, and sine of x is your g, right? All right, here we go. I'm going to try and do this tabular. This is the type of problem that you would take the integral, or you would do integration by parts a couple of times. You'd end up with the exact same integral that you started with, and have to like add a certain number to the other side and then divide. So let's see if we can, get through this. This is going to be a work in progress, but your f is going to be e to the negative 3x. Your g prime is going to be sine of x. And what we're going to do is we are going to integrate down until it looks like we have the exact same thing that we started with. Does that make sense?
Okay.
On the same line. Okay, so this will be negative 3e to the negative 3x. This will be negative cosine of x. You guys with me?
Yep.
Okay. This will be 9e to the negative 3x. This will be
Negative sign.
negative sine of x. We're there. We're already at our place. Okay? It doesn't matter about negatives. Negatives can be brought to the outside. So this is what this is going to look like then. Positive, negative. That's it, right? Now, watch how this works. Yep, good. This is the case where it doesn't go down to 0. This is the case where it just keeps cycling back and forth in the same. So I'm showing you the long ones, how you could use tabular integration. Okay? All right, now watch. This is how this is going to work. Our first term is going to be this, which would be negative e to the negative 3x cosine of x.
Actually,
That will be the first term no matter what. That's this right here. Okay? This one right here is 3 negatives. minus 3e to the negative 3x
Cosine x.
cosine of x. You guys still with me? So those are the first two terms that have nothing to do with an integral. The last piece we don't have. That's the problem here. Because we can't go down to 0, like what Lucas was asking, we don't have a clear third term here. What our third term is this portion right here, but it's the integral of all that. Okay? It's minus 9 of that integral. So just think about it. If I do minus 9 integral e to the negative 3x sine of x, that's where that negative came from, right? Okay? If I have those negatives there, now this integral looks exactly like it does above. Okay? Now, where is that assignment? Let me make sure that we're good on this. Yep, good.
So the one for the first term
Yep.
was positive, and then you went down and another to do the same thing with negative.
So why don't you go any further?
So this is negative is
Because-
positive. Oh, we have to-
Alright, so you don't go any further.
Well, yeah, because we haven't
Cole
taken-
buddy, I love you, but my phone is really getting really fucking hot. So like,
It's still underneath the integral.
this is it.
Able to do it, then
Bye,
we're
buddy.
gonna do